Hi, I'm Hassan, the lecturer here at the Institute of Medical Education, and today we're going to take a look at solutions to Section 3 of ACE's GAMSAT Green Booklet, Practice Test 1, specifically Unit 6, questions 18 to 19. And we're going to be focusing on renal physiology. Now, if you take a look at this stimulus, there's a reason why I have this diagram here. So if you actually do a lot of the hard work before setting the GAMSAT, you wouldn't have to actually read these stimulus. You just have to look at the graph and it's streamlined answering this question very quickly, which is why I'm going to spend just a minute or two just going through this figure here, because if we understand this figure, then when you see this sort of question that you've been presented in the unit, in the GAMSAT, you just have to look at the actual graph. You probably would have seen it 1,000 times, but just bear in mind this is for a dog. So the unit is showing you concentration of plasma glucose in a dog, not a human, but the principle is the same. So let's just assume, I guess, the dog's kidneys work similarly. Similarly to humans. So in normal conditions, the kidneys, they can obviously reabsorb glucose against a concentration gradient by means of sodium glucose transporters, so SGLTs, and they're located in the membranes of proximal tubules, or I guess across the kidney. However, I guess these glucose transporters, they do have a limited capacity. I mean, you can overrun them, a limited capacity in their reabsorption, which means that if you do exceed their reabsorption through these transporters, you are inevitably going to get glucose leaking in the urine. And it's kind of, I guess you can say, a symptom of people with diabetes. And it's obviously something you should be looking out for because diabetes is on the rise, but that's for another time anyway. So if we take a quick look here at this figure, we see that urine here on the left, our filtrate, blood on the right, and in the middle we've got our renal tubules, or the cells that's going to facilitate the crossing of glucose from the urine or the filtrate to the blood. Note here that glucose isn't just going to walk across into your blood. It's not going to just be like, oh, yep, here's my stop, get up and go through the cell and go into the blood. It needs some sort of active transport. It needs energy. So in cells, to make things happen, you use a lot of energy. And how do we generate that energy? We do it via ATP. So that's why we have an ATPase over here, which generates this energy. So what it does is it takes out 3 sodium ions from, say, the renal tubules from the cell into the blood, and that it takes into potassium, and it generates this concentration gradient. And this concentration gradient is going to facilitate sodium into the cell from the urine or the filtrate. So what we call this process here, so the way that the sodium glucose transporters work is by a process called secondary active transport. Now, the reason why we call it secondary active transport is because it's secondary to the primary energy source, which is the ATPase. So it's something that occurs because of this. If this didn't occur here, you wouldn't get this concentration gradient to facilitate sodium and glucose coming into the cell. So it's secondary active transport. And then when glucose gets into the cell, or say the renal tubules here, it accumulates. And then when it hits a certain point, the glucose transporters here facilitate passive diffusion or passive transport into the blood. So you can see how it's a nice, neat system that works, say, in healthy people. However, in people who are morbid, or in this case, in this dog here, with this figure here, if you oversaturate these transporters or you just have too much glucose in your urine, you're not going to catch it all. And you're not going to get it back into your blood, and it's going to pass into your urine. So it's important to know when we're looking at the figure stimulus here, when we look at it, we clearly see that plasma glucose concentration increases. I think it's about, let's say, 2.2 milligrams per mil. When it increases from that point, glucose appears in the urine. So this unit requires you to have some background knowledge in renal physiology, as well as knowing how to read graphs. So if we take a look at the first question, it says for glucose at plasma concentration of 1 milligram per mil, so you can draw a line or point your finger at the graph there. The glucose concentration in filtrate is higher than in urine because, now this is obvious, we just talked about it. The reason why it's higher than in urine is, well, the answer has to be A, is because glucose is actively transported back into the blood. So therefore, it's going to be higher. That's obvious answer. So if we move on to question 19, it says, so if I just get rid of this here. So question 19 says, figure 1 indicates that all glucose is absorbed from the filtrate, and it's either below or above a specific concentration of filtrate or urine. So when we look at the graph, we can see clearly that when we're below a filtrate concentration of 2.2 milligrams per mil, we see that all glucose is absorbed from filtrate, and then once we pass that value, glucose is going to appear at the urine, or glucose appears in the urine. So you can see clearly just by looking at the graph, once we pass that 2.2 mark, we're going to get glucose in the urine. So it has to be below a filtrate level. So think about it. If your filtrate level has a certain amount, after a certain amount, the SGLTs can't take up the glucose anymore, so it's going to appear in the urine. So the answer for 19 therefore has to be A. So with answering this unit, it requires a lot of background knowledge with renal physiology. Now, this is why I employ students, please study as much as you can so that when you do sit the gaps, at questions like this, you can literally fly by, because you don't have to worry about reading too much of a stimulus, because it's a lot of the stuff you already know. It's just about reading the graph here. Now, if you have other comments, so if you have any comments, you can post them in the comment section below. I'd love to help. If you would like me to explain just a bit more why we chose those answers and not the others, ask me, or you can contact us directly. We'd love to help. Thanks for your time. Bye now.